Hello, welcome to my GCSE Science. In this video about the chemistry of the atmosphere, we'll be looking at the greenhouse effect and global warming. First of all, let's look at the greenhouse effect. Here's an image that's not to scale of the sun shining down on the Earth, with the atmosphere, again not to scale, around the outside of the Earth. Energy from the sun travels to the Earth in the form of different types of radiation. The type of radiation that's associated with heat is infrared radiation. So the sun heats up the Earth with infrared radiation. Some of that radiation is absorbed by the Earth's surface, which heats up the Earth, and some is then reflected back into space. If it wasn't for the atmosphere or any greenhouse gases, this would leave the Earth quite cold. But the molecules of greenhouse gases that are in the atmosphere absorb a lot of the infrared radiation on its way out of the atmosphere, thus trapping it within the Earth's atmosphere. This is what's called the greenhouse effect, like wrapping a warm blanket around the Earth. If we didn't have the greenhouse effect, the Earth would be too cold for us to live on, and life as we know it today would never have evolved. Due to the increasing levels of greenhouse gases, which we'll talk about later in this video, many scientists believe that the Earth is warming up too much now. So although the greenhouse effect is a natural and positive effect, if the levels of greenhouse gases get too high, then it's possible we could irreversibly change the climate of the Earth and upset the balance that's evolved over millions of years. You may remember from physics that radiation comes in a variety of different forms with different wavelengths. In this video, we'll be focusing on two different wavelengths of electromagnetic radiation. We've got infrared, which have slightly longer wavelengths. This is what we know as heat energy. And we have ultraviolet radiation, which we can't see but causes damage to our skin. This has a shorter wavelength than infrared radiation, and both are sent to the Earth from the sun. One of the things you may need to explain, especially to get the highest possible marks in the exam, is how the greenhouse effect actually works in terms of these different wavelengths of radiation. So, we mentioned that the sun's energy comes down to Earth in the form of different wavelengths of radiation. And when the Earth's surface emits that infrared radiation back out towards space again. The short wavelength radiation, i.e. the UV, passes through the atmosphere and therefore goes straight back out into space. But the longer wave radiation, i.e. the infrared radiation, is absorbed by greenhouse gases. These greenhouse gases are water vapour, methane, and carbon dioxide. The infrared radiation is absorbed by the molecules of these gases and makes their bonds vibrate, bend and stretch more vigorously, thus raising their temperature. This is how these molecules trap heat in the atmosphere, thus creating the greenhouse effect. So the more greenhouse gases there are, the more energy will be absorbed and the greater the temperature rises around the world. So although there's been some scientific debate over the years about whether or not human activity is actually increasing the levels of greenhouse gases faster than they would normally, for the exam you need to be able to describe a couple of different ways in which human activity can increase the greenhouse gases carbon dioxide and methane. The two main ways in which human activity can increase the levels of CO2 are burning fossil fuels, which we've talked about in the earlier topic on organic chemistry, as this produces lots of carbon dioxide and water vapour for that matter, and deforestation, which is basically chopping down trees. By chopping down trees, we reduce the planet's capacity to absorb the CO2 from the atmosphere. Another thing that can affect the levels of CO2 is the ability of the oceans to absorb carbon dioxide. In general, oceans are really good at absorbing carbon dioxide, and this is one of the ways that over time levels of carbon dioxide in the atmosphere have decreased. But as temperatures rise, the oceans become less able to absorb the carbon dioxide, and therefore it stays in the atmosphere, contributing to the greenhouse effect. Methane is produced in a different way. In general, it's produced from decomposing matter. So things like the existence of swamps, grazing cattle, landfill sites, rice fields, all contribute to the increase in levels of methane in the atmosphere. Now, as I said, there has been some scientific debate about the evidence that supports the idea that human activity has been increasing the levels of greenhouse gases over the last couple of hundred years. Some scientists argue that there are natural fluctuations in the levels of greenhouse gases, and this may be true, but it is now generally agreed that the levels of greenhouse gases have increased in recent years more than would be expected through the natural cycles of the Earth. Some evidence that supports this comes from drilling into ice cores in Greenland, where ice has built up over many centuries, trapping gas within it, and therefore by drilling down into the ice core we can analyse the composition of the air in different periods of history. So while we can now generally agree that greenhouse gases have been increasing, the effects of the increasing levels of greenhouse gases are hard to predict. But it's generally agreed that global warming is linked to this rise in greenhouse gases. Global warming, as it sounds, is to do with the increase in average global temperatures around the world. And it's predicted that over the next 100 years, average global temperatures could increase by about 5.8 degrees Celsius. This might not sound like too much to you, but as an average across the whole world, this could have significant effects on the climate in different regions and on our planet as a whole. And there are 4 main effects that you need to know about. The first is rising sea levels. The increase in temperature could mean that the polar ice caps, i.e. the permanent ice that exists on the North and South poles, starts to melt at a much higher rate than it would normally. This melting ice ends up in the sea and overall causes the sea levels to rise. While this may not have a huge effect everywhere, many countries have built big cities and settlements at or even below sea level, meaning that if the sea levels rise, entire cities could be flooded, leaving millions and millions of people homeless. The second key effect is more frequent and extreme weather events, such as storms, hurricanes, and tsunamis. Some of these would have occurred anyway, but it's predicted that global warming and climate change are making these extreme weather events much more frequent and extreme, causing more damage to buildings, cities, and harm to humans and animals. Changes in temperature also affects the distribution of rainfall around the world, and this could affect food production in different parts of the world. In some areas, it might mean that more food can be produced where it was too dry before. But in other areas, this could mean that important farming industries which people rely on to make a living are no longer possible because the rains don't come. And finally, global warming and climate change can cause stress to fragile ecosystems. This could lead to species extinction of both animals and plants. Finally, you need to know about something called the carbon footprint. You may have heard this term before, but you may not know what it means. And it's actually the total amount of carbon dioxide, as well as other greenhouse gases, that's emitted over the full life cycle of a product, service, or event. This is a really useful measure when individuals or countries are aiming to reduce their environmental impact, especially related to the greenhouse gases emitted. There are websites that allow you to calculate your own carbon footprint so that you can find out what the total amount of carbon dioxide and other greenhouse gases is produced by your lifestyle. As you may know, there are all sorts of things that you may do in your day-to-day life which produce these greenhouse gases, especially carbon dioxide. But there are some ways of reducing the emissions of greenhouse gases. On a large scale, one thing that can be done is something called carbon capture and storage. This is where large amounts of CO2 is pumped deep underground, into porous rocks or old oil fields. However, this is quite an expensive process, and so we should be looking for other alternatives if possible. Another thing that individuals can do is lead towards more plant-based diets and eat less meat. This will reduce the demand for beef, which is a leading cause of the production of methane, as well as reducing the emissions associated with transport of animals from farms to where you eventually buy them in shops. There are lots and lots of other ways you can reduce your carbon footprint. Many countries have already started taxing fossil fuels, especially big cars which consume a lot of fuel and therefore release a lot of carbon dioxide emissions. It's also important that we do more research into alternative energy so that we can find other ways of producing electricity which don't produce as many greenhouse gases. For example, biofuels, such as ethanol, are carbon neutral because although they produce carbon dioxide when they're burnt, the carbon dioxide produced is equivalent to the amount of carbon dioxide that was absorbed when that biofuel was produced. So overall, there's no more carbon dioxide in the atmosphere after burning the biofuel compared to before. Other things we can do are insulate our homes to make sure that energy isn't being wasted. We can also plant trees, which is called reforestation, to increase the planet's capability of absorbing the CO2 that's produced back into those plants. There are many more things that individuals and countries can do to reduce their emissions. And if you're interested in this, there's lots more to find out about. But for the exam, you just need a few key ways that humans can reduce the emissions of greenhouse gases. So this will be enough. And that's it. It may seem like a lot to take in, so of course, as always, feel free to watch the video as many times as you need. Here are a few keywords for your reference. I hope you enjoyed this video, and I look forward to seeing you again soon on another video by My GCSE Science.